Welcome to my channel Ganit Mathematics Classes. Today we are going to start Mathematics class of 8 and the first chapter is Rational Number. So before starting rational number, let us review some concepts of natural numbers, whole numbers and integers. What are the natural numbers? The numbers which we can count is called natural numbers. Okay, simply 1, 2, 3, up to infinity. That means it doesn't have any end. These numbers are called natural numbers. Now suppose you can ask them whether 1000 is a natural number. The answer will be yes, 1000 is also a natural number. Ma'am, 2 lakhs, is it a natural number? Yes, 2 lakhs is also a natural number. Okay. Next come to the whole numbers. All natural numbers including 0 is called whole numbers. Okay. That means whole number starts from 0. 0, 1, 2, 3 and onwards. This is up to infinity. Okay. So, the only difference between a natural number and whole number is that natural number starts from 1 but whole number starts from 0. 0 to infinity. That means any number starting from 0, say 2000. This is also a whole number. Okay. Then suppose 3 lakhs, 50,000, 499. This is also a whole number. Okay, and it will go up to infinity. That means it doesn't have any end. Now come to integers. In earlier classes we have learned that in our number system, as we have the natural numbers, that means positive numbers, whole numbers, 0 and positive numbers. Now what are the integers? The collection of whole numbers along with the negative numbers is called integers. That means -3, -2, -1, 0, 1, 2, 3 up to infinity. And here also in the left side also minus infinity. Okay, these are integers. I think up to here it is clear. Next come to rational numbers. Okay, now before starting rational number, let us revise our previous concept. We have learned about fractions in our earlier classes. I think from class 4 onwards, we have learned about fractions. What are fractions? How the number looks. So, fraction looks like this: 1 by 4, it is a fraction. 2 by 5, it is also a fraction. Okay, these are fractions. Now, what is rational number? A number which can be written in the form P by Q, where P and Q are both integers and Q is not equal to 0 is called rational numbers. That means the numbers that we can write in P by Q form. Okay, and both are integers and Q cannot be equal to 0. Okay, that means denominator cannot be equal to 0. Okay, for example, we can say 1 by 2, this is a rational number. We have written it as P by Q form and the denominator, that means Q, is not equal to 0. Say -3 by 5, this is also a rational number. Why? Because -3 is also a integer and 5 is also a integer. So that's why -3 by 5 is a rational number. Now we can write 8 by -9. This is also a rational number, as 8 and -9 both are integers. Okay. Now you can ask them whether 2 is a rational number. Think, is 2 is a rational number? The answer will be yes, because we can express 2 as 2 by 1. P by Q form and Q is not equal to 0. That's why 2 is a rational number. Similarly 10 we can write 10 by 1. That means 10 is a rational number. Then say 1500. This is also a rational number because 1500 we can write it as 1500 by 1. P by Q form where the denominator, that means Q, is not equal to 0. Now you can ask that, ma'am, is 0 is a rational number? Think. Yes, 0 is also a rational number. Why? Because 0 we can write as 0 by 1 or 0 by 2 or 0 by 100, anything. Okay. P by Q form, Q is not equal to 0. The condition is that Q cannot be equal to 0, but P can be 0. That is not our condition. Okay, that's why 0 is our rational number. But 1 by 0, this is not a rational number because Q is equal to 0. And 1 by 0, can we define it? No, this is undefined. So that's why 1 by 0 is not a rational number. I think now your concept of rational number is clear. Let us move to the next topic, the properties of rational numbers. Okay. We have already discussed in our earlier classes the properties of, say, natural number, then whole number, integers. What are the properties? Closure properties, associative, distributive. Okay, these are the properties. So, first we will discuss about closure property. Okay. See what is the heading. If A and B are two rational numbers, then A plus B under addition, A plus B must be a rational number. Let us consider two rational numbers, say half and 3 by 5. Okay. Now let us add them. Half plus 3 by 5. Now what is the LCM of 2 and 5? 2 and 5, the LCM will be 10. Here it is 2 and the LCM is 10. That means we have to multiply the numerator by 5. So 5 into 1 is 5 plus, and here the denominator is 5 and the LCM is 10. So we have to multiply the numerator by 2. 3 into 2 is 6. That means equal to 11 by 10. Now here we got the answer. It is 11 by 10 and it is a rational number. That means rational numbers are closed under addition. Okay. Now next come to subtraction. If A and B are two rational numbers, then A minus B should be a rational number. Let us take example, say 3 by 4, and let us take a minus rational number, negative rational number, say 5 by 7. Okay. So 3 by 4 minus 5 by 7. Okay. So 3 by 4 minus plus 5 by 7. Now what is the LCM of 4 and 7? 28. So 4 and it is 28. So we have to multiply 3 with 7. 21 plus 7 and 28. So we have to multiply 5 with 4. So 20 equals to 41 by 28, which is a rational number. That means rational numbers are closed under subtraction as well. Next we will check for multiplication. If A and B are two rational numbers, then A multiplied by B is also a rational number. So let us take, say, 10 by 11 and 9 by 7. Let us multiply them. 10 by 11 multiplied by 9 by 7. So numerator multiplied by numerator and denominator multiplied by denominator. So it is 90 by 77. Again a rational number P by Q form, and Q is not equal to 0. So rational numbers are closed under multiplication as well. Now let us come to division. So if A and B are two rational numbers, then A divided by B should be a rational number. So let us check. Let us take example, say 2 by 3 and 0 by 4. Okay. So 2 by 3 divided by 0 by 4 equal to 2 by 3. How to do this? It will become multiplication and we have to just take the opposite, that means 4 by 0. That means 8 by 0. 8 by 0, that means P by Q form, but Q is equal to 0, which is not a rational number. Okay, that means rational numbers are not closed under division. Okay, so what we got? That rational numbers are closed under addition, rational numbers are closed under subtraction, rational numbers are closed under multiplication also, but rational numbers are not closed under division. Okay, now come to the next property. Next is commutative property. So if A and B are two rational numbers, then under addition, A plus B should be equal to B plus A. Okay, so let us take example, say half and 3 by 4. A plus B, half plus 3 by 4 equal to, the LCM will be what? 4. 2 and 4, so 1 multiplied by 2. 4 and 4 same, so it will remain as same. 5 by 4. Now B plus A, let us find out 3 by 4 plus half. Again the LCM will be 4. 3 plus 2 equal to 5 by 4. That means what we got? Half plus 3 by 4, same answer, equals to 3 by 4 plus half. Okay, that means rational numbers are commutative under addition. Okay, now let us check for subtraction. So if A and B are two rational numbers, then A minus B should be equal to B minus A. Okay, let us take same example, half and 3 by 4. Same example I have taken. So first we will do half minus 3 by 4. The LCM will be 4. 2 minus 3 minus 1 by 4. Gone. Next is 3 by 4 minus half. That means B minus A here we are doing. So LCM is 4. 3 minus 2. 1 by 4. Is the result same? It is this minus 1 by 4 is 1 by 4. That means half minus 3 by 4 is not equal to 3 by 4 minus. That means what? Rational numbers are not commutative under subtraction. Okay. Okay, next come to multiplication. Okay, I think addition and subtraction are clear for you. Let us remove this. Okay. Now multiplication. Let us take negative numbers. Say minus 1 by 3 and one positive rational number. Say 4 by 5. Okay. So minus 1 by 3 multiplied by 4 by 5. So numerator into numerator and denominator into denominator. So minus 4 by 15. Okay. Now B multiplied by A. 4 by 5 multiplied by minus 1 by 3. So 4 multiplied by minus 1, 5 multiplied by 3. So minus 4 by 15. Answer is same. Okay, that means minus 1 by 3 multiplied by 4 by 5 is equal to 4 by 5 multiplied by minus 1 by 3. That means A multiplied by B is equal to B multiplied by A. Okay, that means rational numbers are commutative under multiplication. Okay. So up to here we have done for addition, for subtraction and for multiplication. And the last one is for division. Okay, so let us remove, that means this is also right. For division, let us take a very simple example, 4 by 5 and say 3 by 7. Okay, now division, 4 by 5 divided by 3 by 7. So 4 by 5 multiplied by 7 by 3, which will be equal to 28 by 15. Okay, now 3 by 7 divided by 4 by 5. So 3 by 7 multiplied by 5 by 4. So 15 by 28. Okay, that means 4 by 5 divided by 3 by 7 is not equal to 3 by 7 divided by 4 by 5. That means A divided by B is not equal to B divided by A. Okay, that means rational numbers are not commutative under division. Okay, that means rational numbers are commutative under addition and multiplication, but not commutative under subtraction and division. Okay, I think it is clear now. Now come to the next property, associative property. Associative property says, if A, B, C are three rational numbers, then under addition, A plus B in a bracket plus C will be equal to A plus B plus C. Okay, let us take example, half 2 by 3 and say 4 by 6. Okay, so half plus 2 by 3, 4 by 6. So equal to, the LCM is 6. So it is 2, 4 plus 4 by 6. That means 6 by 6 plus 4 by 6. That means 10 by 6. Okay. Now next part is half will be outside and in bracket we will write 2 by 3 plus 4 by 6. Okay. So half plus, again the LCM will be 6. So 4 plus 4, half plus 8 by 6. So again here we can remove this bracket as well. No need. So the LCM will be 6. So 3 plus 8, 11 by 6. Okay, that is 3. 7 by is 11. Sorry. Okay, so ultimately what we got, that A plus B plus C is equal to A plus B plus C. Okay. So that means what, rational numbers are associative under addition. Okay. Is it clear for you? Okay, next come to subtraction. Okay, let us clear it. So for subtraction also we will take 3 numbers. Okay. So here we have to show that if A, B, C are 3 rational numbers, then A minus B minus C is equal to A minus B minus C. Okay. Let us take 3 rational numbers, say 3 by 4, 2 by 5 and 1 by 10. Okay. And now let us start. A minus B, that means 3 by 4 minus 2 by 5 minus 1 by 10. So here our LCM will be 20, 15 minus 8 in bracket and minus 1 by 10 in outside. So 20, it will be how much? 7 by 20 minus, so LCM will be 27 minus Means 5 by 20. Okay. Now A 3 by 4 minus in bracket 2 by 5 minus 1 by 10. We will do the bracket work at first. 3 by 4 minus the LCM will be 10. 4 minus 1. So 3 by 4 minus 3 by 10. What is the LCM? 20. So here 15 minus 6. So 9 by 20. Are the results same? No. That means what? Rational numbers are not associative under subtraction. Okay. Just erase it. So we got that rational numbers are associative under addition but not associative under subtraction. Now let us check for multiplication. Now for what multiplication, what we will write? If A, B, C are three rational numbers, then A multiplied by B multiplied by C is equal to A multiplied by B multiplied by C. Okay. So let us take numbers half minus 3 by 4 and say 7 by 5. Now first two numbers will come in bracket 7 by 5. So it will be minus 3. Okay, 1 into minus 3 is minus 2 into 4 will be 8 multiplied by 7 by 5. Okay, now numerator into numerator, that means minus will come here. 3 into 7 is 21 and it is 40. Okay, next is half will come outside multiplied by B. Minus 3 by 4 multiplied by 7 by 5. So half multiplied by 20 minus 3 into 7 is minus. Okay, now 1 into minus 21 is minus 21 and 2 into 20 is 40. So the results are same. That means rational numbers are associative under multiplication. Okay, so we got that associative, rational numbers are associative under addition and multiplication but not associative for subtraction. Now we will check for division. Last one is division. So if A, B, C are three rational numbers, then A divided by B will be in bracket divided by C will be equal to A divided by B divided by C. Okay. So let us take example. We will do in this side of our board. What numbers we can take? Let us take very simple numbers to make it understand. 6 by 8. No. Say 6 by, wait, 6 by 7. We'll write it as 6 by 7. Okay? 6 by 7. Okay. So first half divided by 3 by 4 divided by 6 by 7. Okay. So half multiplied by 4 by 3 divided by 6 by 7. Keep it as it is. Okay. First we will do the bracket part. So 4 by 6, 6 by 7. So it is 4 by 6 multiplied by 7 by 6, 28 by 36. Okay. Now we will check for the second part. Half will be outside divided by 3 by 4 divided by 6 by 7 will be inside the bracket. So keep it as same. Let us do the bracket work first. Multiplied by 7 by 6. So half divided by 21 by half. Now we will do it. 2 and 24 is 12. So 12 by 21. Are the results same? No. That means rational numbers are not associative under division. Okay. So what we get here? That rational numbers are associative under addition. Rational numbers are not associative under subtraction, but rational numbers are associative under multiplication, but not associative under division also. Okay. So next is our distributive property. Okay. Distributive property says if A, B, C are three rational numbers. Okay. So A multiplied by B plus C equal to A multiplied by B plus A multiplied by C. Okay. This is very important. Now let us take three rational numbers. Say 9 by 8. Okay. First we will do the left hand side. 3 by 4 plus 9 by 8. So half multiplied by 8, 6 plus 9 inside the bracket. So half multiplied by 15 by 8. So 15 by 16 is the answer. Okay, now half A into B, that means half multiplied by 3 by 4 plus half multiplied by 9 by 8. So it will be 3 by 8 plus 9 by 16. So LCM is 16, 6 plus 9 is equal to 15 by 16. This sounds really very beautiful. Okay, so the results are same. Okay, that means this is the distributive property of multiplication over addition. That means if A, B, C are three rational numbers, A multiplied by B plus C equal to A multiplied by B plus A multiplied by C. Okay, and this is very important. Now let us check for distributive property of multiplication over subtraction. Same again. If A, B, C are three rational numbers, then A multiplied by B, okay, let us write here, A multiplied by B minus C will be equal to A multiplied by B minus A multiplied by C. Okay. Let us take some examples. What numbers we can take? Say 3 by 4, 5 by 7, 8 by 9. Okay. So first we will write 3 by 4 multiplied by 5 by 7 minus 8 by 9. Here in this chapter, calculations are really very important. Be very careful while doing the calculation. 63, the LCM is 63. Okay, so here 5 multiplied by 9 minus 56. So, see, be very careful while doing the calculations in this chapter. Okay, minus 11. Okay, so it is minus 33 by minus 33 by 252. Now let us check for the second part. So A multiplied by B, 3 by 4 multiplied by 5 by 7 minus A multiplied by C, 3 by 4 multiplied by 8 by 9. Okay, 15 by minus 36 by So what is the LCM? 28 and 36. Let us take out the LCM. 2. And it is 7 and 9. Okay, so here we can stop. So 4. 252. So LCM is 252. Now 28. 28. Let us make 28 here. 4 into 7 is 28. We are left out with 9. So 9 multiplied by 15, how much? No. 135. So minus 36, that means, let us see the color. Now 2 to 4 and 9 is 36, are left with 7. Okay, so 7 multiplied by 24. I am doing the calculations over here. Okay, so minus, as this is the bigger number, 168 is bigger number, so we have to put the minus sign in the answer. 8 minus 5 is 3 and 6 minus 3 is 3. 1 minus 1, 0. No need to write. So see, we have got the same result. Okay, so this is the distributive property of rational numbers of multiplication over subtraction. Okay, these two are really very important. Yes, and this to solve the equations or problems later. Next is our additive inverse or negative of a number. Okay, if sum of two numbers is 0, then the numbers are called additive inverse of each other or negative of a number. Suppose we have given a number A. Okay, we have to add something with A to get the result 0. Okay, so what we should add with A to get 0? That means A plus minus A. If we write like this, plus minus is minus, minus A, so 0. Okay, so that means if 1 by 2 is a rational number, then the additive inverse of 1 by 2 should be minus 1 by 2, because 1 by 2 plus minus 1 by 2 is equal to 1 by 2 plus minus is minus 1 by 2. Half minus half is equals to 0. Okay, so if you are given a number, say 3 by 5, what is the additive inverse of 3 by 5? The answer will be minus 3 by 5. Now suppose you are given minus 1 by 4. What is the additive inverse of minus 1 by 4? It is minus of minus 1 by 4. That means minus minus plus is 1 by 4. Okay, so this is the concept of additive inverse or negative of a number. Next is multiplicative inverse or reciprocal of a number. Very important. Okay, if the product of two numbers is equals to 1, then the numbers are called multiplicative inverse of each other or reciprocal of each other. Now if a rational number is given A, what we should multiply with A to get 1? Okay, it should be 1 by A. If that means A and A will be cancelled out, so we will left with 1. Answer will be 1. Okay, so if we write say 2, what we multiplied with 2 to get 1? That means 1 by 2, 2 and 2 will be cancelled out and we are left with the answer 1. Okay. Similarly, if you are given 2 by 5, what is the reciprocal or multiplicative inverse of 2 by 5, it will be 5 by 2. Now if you are given minus 6 by 7, minus 6 by 7, what is the multiplicative inverse of minus 6 by 7? It will be 7 by minus 6. Okay. So in today's class we have learned about rational numbers and its properties. We have discussed thoroughly the properties of rational numbers. Okay. So in our next class we will discuss about that means your exercise 1.1. Okay. And today we will end our class here only. Thank you for watching my video, and if you like my class, so don't forget to like, share and subscribe.